Okay, so related rates. Number 3, one car leaves a given point and travels north at 30 miles per hour. So let's do a little picture again. Okay, so he travels north 30 miles per hour and another car leaves 1 hour later. So an hour later he leaves, and so once the first car, which is heading north, is 1 hour at 30 miles per hour, so once it traveled 30 miles, okay, so he's here, then the second car leaves and heads west at 40 miles per hour. So this is the distance that he traveled, the second car, and this is the distance traveled by the first car once the second car leaves. Okay, so we want how far is the distance between both cars changing. So this distance I'm going to call Z. Okay, when the second car has been traveling for 1 hour, so basically when Y is 40. You okay with this? Okay, so let's see what we know. We are given that X is the car, distance X is increasing at 30 miles per hour, so dx dt is equal to 30. And we know also that dy dt is also, it's given to us as 40. Okay, we're looking for dz dt when 1 hour after, when the second car drove for 1 hour, so basically at 40 miles per hour, so basically when Y is 40 miles, and also when X is 30. That's my problem. All good? Okay, so I'm going to find a relation between X, Y, and Z. So now there's 3 variables. Okay, so this is new, but we can still relate them using Pythagoras. So this side squared plus this side squared equals this side squared. So X plus 30 squared plus Y squared is equal to Z squared. And I'm going to find the derivative of everything. So 2 times X plus 30 times dx dt plus 2y times dy dt is equal to 2z times dz dt. Okay? That's what you did, I guess? Okay, so now I'm going to see what I know. So X, we know it's 30. Dx dt is also 30. Y is 40. And dy dt is also 40. Dz dt is what I'm looking for. And I'm missing just the Z. Okay, but the Z I could find when X is 40, when X is 30 and Y is 40. So X is 30, Y is 40. I could find what that is. Okay, so I'm going to use to Pythagoras theorem. No, sorry, this is not 30, this is not 40. I will get cut here. This is 60. Right? My Z here is 40 and 60, it's 30 plus 30. So I do Pythagoras theorem, 60 squared plus 40 squared, square root 72.11. So I have my Z also. And that's it. Okay, I could get rid of the 2's. And so I have 30 times 30, 60 times 30. So I'm going to move up a bit. So 60 times 30 plus 40 times 40 is equal to 72.1 times dz dt. And so I could find what dz dt. Let's do the calculation. So this is 1800 plus 1600. So it's 3400. So there you go, 47.15 miles per hour. Okay, which is the correct answer. So what do we have here? I have a cylinder. And the radius is increasing. So I have a radius here, R, and I have a height here, H. Okay, what's given to me? The radius is increasing at 1 meter per hour, so dr dt, this is given to me as 1. And the height is decreasing, so dh dt is decreasing at a rate of 4, so minus 4. Okay, right? So what you did? You put minus, right? Because it's decreasing. So every hour, it just loses 4 meters. At a certain instant, the base is, the radius is 5 and the height is 8. What is the rate of change of the volume? So basically we're looking for, that's a very easy question. So the rate of change of the volume when the radius is 5 and when the height is 8. This is what we're looking for. Okay, so relation between volume, height, and radius. So V is area of the base times the height. And now I'm going to do the derivative. Okay, so dV dt is equal to, so now you have to be careful because there's a multiplication, right? So you do product rule. So the derivative of pi r squared is 2 pi r dr dt times h plus pi r squared times the derivative of h, which is dh dt. Okay, do you understand this? Okay, so that's the point of this problem, is to just remind you to be careful, and when there's a product rule, to use it. Okay, so you cannot just do derivative of pi r2 times derivative of h, right? It's a multiplication, product rule stands. That's it. And at this point, we just put in what we know and what we're looking for. So we're looking for dv dt. We have the radius, it's given to me, it's 5. dr dt is 1. H is 8. This is still 5. dh dt is -4. That's it. So 8 times 5 times 1 is 40 times 2 is 80. So 80 pi minus, and here I have 25 times 4 is negative 100. So minus 100 pi. And so the answer is negative 20 pi meters cubed per hour. Okay, which matches the answer up there. Are there any questions? Okay, let's do last one. Okay, so let's label things here. So I'm looking, this I'm going to call X. Okay, and of course I'm looking for dx dt. When the angle is 30 degrees. So when theta is 30 degrees. That's what I'm looking for. And what's given to me? D theta dt is given to me. So how are we going to calculate this? It's 5 turns per minute. Okay, 5 turns per minute. So it's 5 times 360 degrees per minute. So 5 times 360 is 1800 degrees per minute. This is the rate at which theta is changing. Are you okay with this? Okay, so the only thing I need now is to find a relation between theta and x. What's the relation that you see here? No, you don't see it? Right,
Tangent?
Is it what? Sorry?
Tangent?
Yeah, very nice. So tangent of theta is equal to x over 1, right? Opposite over adjacent. And I'm ready to derive. So the derivative of tangent is, we know secant squared theta times d theta dt is equal to dx dt. And that's it. Theta, I know it's 30 degrees. D theta dt, we just figured it out, is 1800. And I could find now dx dt. Okay, so secant squared of 30. So sine of 30 is, cosine of 30 is, so let me just do it like this. So 1 over cos squared of 30 degrees times 1800 is equal to dx dt. Cos of 30 is root 3 over 2. Squared is 3/4, so 4/3. Times, okay, so I'm guessing that, oh, it's in kilometers, okay. $1,800, so I have no idea what this answer means. So my guess here is that they put it in radians. But why is what I did wrong? So let me see. Instead of putting it in degrees here, let's say I put it in radians. So 5 times 2 pi, so 10 pi. Yeah, that's why. That's 10 pi. So this here would be 10 pi. And you will get dx dt will be 40 pi over 3. What's wrong with putting it in degrees? Yeah, we have to put it in radians because radians is actually a measure of the arc. Okay, so I should have put it in radians. Okay, so instead of degrees per minute, do radians per minute. Perfect.
But then why can we plug in 30 degrees to the secant squared?
It doesn't matter. You could write here instead of 30 degrees, you could write pi over 6 and turn your calculator in radians, and you'll still get root 3 over.
Oh, okay, as long as you switch your
It
calculator.
doesn't matter. Okay, so how do I get 10 pi? Okay, so 10 pi, so it's five turns. It's 5 turns per minute, and each turn is 2 pi. So 5 times 2 pi.